to start at the beginning. We had a problem. Tan theta equals negative 5/3, and theta's in the second quadrant. Use trig identities to find secant theta, but then we went back and said we needed exact values. So then we went to use Pythagorean identity. We use that. Now we're going to find cotangent negative theta. Okay, that's where we are. Okay. So here, finding negative cotangent theta, we have negative 1 over tangent. So we have a negative of a negative. What's 1 divided by anything? What do we do when we divide by 1? 1 divided by anything.
Flip the second number and you multiply or reduce.
Yes. And every time we do that, what happens to this number on the bottom? It flips. And if it's just a 1 on the top, it simply is 3/5. Negative of a negative becomes a positive. So negative cotangent theta is simply 3/5. But if I asked you, because I believe we all know, if you have tangent to get cotangent, you just flip it. Okay? But why? Because they're reciprocal functions. So if I ask to see your work, could you show it to me? Yes. All right. Maybe let's just start over and do another one. Every day. Yes, ma'am. It said the theta was in the second quadrant. Yes. Well, think about quadrant 2. Cotangent would be 2. Okay, guys. I'm having a one-on-one conversation, but it would probably be good for everybody to hear, or at least be quiet enough so that she can hear me. Okay. So cotangent in the second quadrant is what? No, it's negative. Okay. But then when we want the negative angle identity, it means we want the opposite of that. So we're going to change the sign. So cotangent, yes, in the second quadrant is negative. But when I want the opposite of that, where it's going to be positive. Because really they flipped it to the bottom to be in the third quadrant. Okay. All right. If I give you another one, if cotangent theta, no, cosine, let's say the cosine theta. Cosine theta equals 5/8. And theta is in quadrant 4. Let's space out my n. Can you find use trig identities to find exact values? All right, maybe I'll just write all of them. Sine theta. Tan theta. And secant of negative theta. Yes, find all 3. 1, 2, 3 problems.
Oh, I thought you said you were going to write all the trick.
Oh, no, I'm going to write all the questions. Last time I just wrote 1 at a time. And I only did 2.
Oh, great.
Sorry. using three different, you should not use the Pythagorean identity on all of them. You should use it at least once, yes? Could you use it on two? Which ones did you use it on? Could work. Okay, I seem to have whose pencil pouch did you steal? Okay. You're borrowing. That's awesome. That's a lot of stuff in there. Oh, you know what? Those answers will be wrong then. You know why? That's it. Use trig identities. So if you just drew a triangle, resolved it, go to count it wrong. Or at least take off lots of points.
Which we don't show the work at all because all the work's on the calculator.
I'm gonna count it wrong. Sometimes, mainly this chapter, is I must see your work. You will use these identities because they will become very helpful in showing your work. I agree. I know you don't need every single step. You don't have to have every single step. But I do need to see something like 5/8 squared plus sine squared equals 1. That's a great thing to have. If you want to use where we rearranged it to solve the sine theta, you could do that. So then in this step, I might say sine squared theta equals 1 minus, and then what is 5/8 squared? 25 over 64. Or maybe, it depends on which steps you need. What is 1 when we have common, to get common denominators with that 64? So 64 over 64 minus 25 over 64. So now what's 64 minus 25? Something like 30 what? 39 over 64. And maybe I go ahead and take the square root because I know I'm going to have to. Square root of 64 is going to be 8. I mean, if you want to skip a step, maybe I shouldn't yet. Which quadrant are we in? Do I need to think about positives and negatives when you take the square root? It can be positive or it can be negative. Which quadrant are we in? The fourth. So sine theta should be what? Negative. So negative square root of 39 over 8. Should there be a logical statement that says sine and cosine have to have the same denominator? Why?
Because they're both over the hypotenuse.
They're both over the hypotenuse. And the hypotenuse is going to be 8 in this triangle. Okay? So now, eventually, when it doesn't say, hey, solve this, use this to solve it, you can draw a triangle. Okay? But when it says what to do, you have to do it. Now, tangent. John, tell me how you found tangent.
Well, first, I used the reciprocal identity to find secant, and then I used the Pythagorean identity of tan squared theta plus 1 equals secant squared theta.
So you said tan squared theta plus 1 equals 8/5 squared. Perfect. You could totally do it that way. Can I show you a different way to do it? Did anybody do it differently? The quotient identity, if you have sine and you have cosine, you can use that. They both work. And I didn't specify which one to do, so you could have used either one. So I'm going to scroll just a little bit. Why they shouldn't all be on one page. All right, so tan theta. If you said tan theta equals sine over cosine. Can we do that? What's sine? And what was cosine? I think it was 5/8. Fraction divided by another fraction. Keep. Change, flip. So we have negative square root of 39 over 8 times 8/5. All of our 8s will reduce. And it's already given to us. It's negative. We know in the fourth quadrant that tangent's going to be negative, but it gives it to us right here. Negative 39, square root of 39 over, not 8, over 5. What I was writing. Okay. If you had done the Pythagorean identity, it would have worked as well. Last but not least, secant negative theta. Which trig identity are we using? Negative angle first, probably. Find another color. So secant negative theta. On your negative angle, secant negative theta became what? It was simply equal to secant theta. Negative angle identity, this one does not pull the negative on the outside. Do you remember why? No.
Because it's related to cosine.
Okay, it's related to cosine. Why did cosine not? It's never negative. It's positive in the fourth quadrant, but does that have anything to do with it? Because negative angle identities, no matter where theta is, if I have cosine or secant, negative of an angle, what's that always going to be? Cosine negative theta. Secant negative theta. Will always be positive. Did I say cosine's always going to be positive? Did I say cosecant is always going to be positive? Not cosecant. Secant always going to be positive. No. But it will always be the exact same as whatever theta is. Okay? Whether it's secant negative 150 or secant of 150, they'll be the same values because they are even functions. Okay? Even functions are the only ones you can do this with. Okay? So after you change it with your negative angle identity and realize that negative is not important, are you chewing gum? not like to try to hide it either. So, after you use the negative angle identity, what do we do next? Reciprocal identity. So secant theta equals what? 1 over cosine theta. Do we know what cosine theta is? I think it was 5/8. I've scrolled down. So what is 1 divided by 5/8? 8 fifths. Okay. We're going to move on and do one more thing before we go. Rewriting. We did a little bit. Rewrite this in terms of that. Okay, I think we did that the other day, so we're going to pause on that one. All right. What if I asked you to add something? Okay. What if I asked you to add tan theta plus cotangent theta, but I want them in terms of sine and cosine? So I want you to add this, but give the answer, how do they say it? Write tan theta plus cotangent theta in terms of sine theta and cosine theta, and simplify. Simplify your expression. There's no equal sign. It's just an expression. What might you do first on the back? Can you find tangent in terms of sine and cosine? Which one is that? Quotient identities. Tangent theta was what? Sine over cosine. Well, what is cotangent theta in that quotient identity? Cosine over sine. So the first thing we do is we're going to write it in terms of sine and cosine. Now, how do we simplify fractions with different denominators? What in the world do we do when we add 1/2 plus 1/3? What? You're adding. It's addition. So my little thought bubble. 1/2 plus 1/3. What do we do? Common denominators. Do they have anything in common? Do 2 and 3 have anything in common? Okay. Technically that answer is no. So we multiply them together. 2 and 3 don't have any factors that are the same. Okay? Just like sine and cosine don't have any factors that are the same. They have nothing the same. So what do we do? How do we get to 6? How do we get something over 6? Now in your brain, you know what you do. I'm going to take you back to like 5th grade. Okay? Where they made you write it out. Okay? Because we're not dealing with simple fractions anymore. We're dealing with a little bit more complicated things. But you need to remember the simple to do the complicated. Okay? And you need to remember the details. So how did we get this denominator of 6? Okay, very close. Did I just say 2 times that? Sorry, not 2, 3. So I need to multiply this by 3 over 3. We multiply it by 1, right? 3 over 3 is 1. So we would multiply 3 times 1 is 3. 3 times 2 is 6. And we would get that fraction. Equivalent fractions, 5th grade. And we multiply this side by what? 2 over 2. Because we simply just multiplied it by 1. We didn't change anything, right? So 1 times 2 is 2. 3 times 2 is 6. And we can add them together. So we can add the top. The top becomes 5. The bottom stays at 6 the same. Okay. So now, sine and cosine. There's nothing in common. What do we do? take this denominator here, multiply it by the other side, correct? So we're going to take this denominator here, multiply it by the other side. Sine theta over sine theta. Okay? We're going to take this denominator and multiply it by this side. Cosine theta over cosine theta. Do we all know I just multiplied each fraction by 1? So did I change anything about the fraction? No. But now all of a sudden, let's simplify our fractions. What do we get on top? Sine squared theta. What do we get on the bottom? Sine times cosine. Over here, we're going to add. What do we get on top? What's cosine times cosine? Cosine squared theta. What do we get on the bottom? Sine theta, cosine theta. So now that we have common denominators, can we add these things together? Yes. So what do we do with the top? You simply add them. Sine squared theta plus cosine squared theta. But then we have the denominator as just 1. Sine theta times cosine theta. Are we done? Could something be more simplified? Do you recognize anything? Do you see a Pythagorean identity with the squares? The top sine squared plus cosine squared is simply what? Okay, I generally don't put equal signs because there is no equal sign. We're just simplifying. So I'm not going to put equals. I'm just going to scroll because that's what I would like to see on your paper. Is it to start at the beginning and just funnel down. Okay, so sine squared plus cosine squared is simply 1 divided by sine theta, cosine theta. What can you do? Can you do anything with the bottom? Just sine times cosine, that is nothing. So we started, what is tangent plus cotangent? And we wrote it as a simple fraction, one number over another, just in terms of sine and cosine. Okay? Boom. This is chapter 5. That's it. You're going to circle it. You're done. Yep. Do I?
We're definitely going to talk about
From this point forward. Oh, perfect. Put it right there. All right.